Hi everyone, welcome to my YouTube channel. Are you watching this channel first time? Please subscribe, like and share. In today's video, we are going to study an important topic from digital electronics, that is a 4 to 1 multiplexer and Verilog code for 4 to 1 multiplexer. The multiplexer is also known as MUX. This concept is very important for the examinations, interviews and practical understanding. So let us learn it step by step in a simple way. Let's see what is a multiplexer first. A multiplexer is a combinational logic circuit. It selects one input signal from multiple input signals and forward it to a single output line. That is why a multiplexer is also called a data selector. Now let's see what is a 4 to 1 multiplexer. A 4 to 1 multiplexer is a multiplexer that has 4 data inputs, 2 select lines and 1 output. Based on the values of the select line, only one input is connected to the output at a time. Is it clear? Now let's see the inputs, select lines and the outputs. In this case, the data inputs are I0, I1, I2 and I3 and the select lines are S1 and S0. The output is Z. The select line control which input appears at the output Z. Now let us see why two select lines. In this case, I already told you that there are 4 data inputs, data lines and 2 select lines, right? Now let's see why 2 select lines. Here, to select one input out of 4, we need 2 select lines because 2 raised to 2 is equal to 4. So, the select lines S1 and S0 can form 4 different combinations. So, the combinations are 0, 0, 0, 1, 1, 0 and 1, 1. Now, let's see the truth table of a 4 to 1 multiplexer. See, I already told you that it has 2 select lines. They are S1 and S0 and one output, that is Z. So here we are having 4 different combinations, right? 0, 0, 0, 1, 1, 0 and 1, 1. If both inputs are 0, 0, then you will get an output as I0. When S1 is equal to 0 and S0 is equal to 1, then the output Z is connected to the input I1. Clear? Then if S is equal to 1 and S0 is equal to 0, then output Z is connected to input I2. If S1 is equal to 1 and S0 is equal to 1, then the output Z is connected to the input I3. So only one input is selected at a time depending on select lines S1 and S0. Using the truth table, we can derive the Boolean expression for the output Z. The Boolean expression is Z is equal to S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S0 I3. Now I will explain each term one by one. Take the first term, that is S1 bar S0 bar I0. This means S1 is equal to 0, S0 is equal to 0. So the input I0 is selected. Consider the second term, that is S1 bar S0 I1. This means S1 is equal to 0, S0 is equal to 1. Input I1 is selected. Take the third term, that is S1 S0 bar I2. It means S1 is equal to 1, S0 is equal to 0. So the input I2 is selected. Consider the last term, that is the fourth term, S1 S0 I3. It means S1 is equal to 1, S0 is equal to 1, so that input I3 is selected. Now let me explain a Verilog code for a 4 to 1 multiplexer. I will explain this code line by line and also explain why each statement is used so that even a beginner can understand it clearly. This explanation is very useful for VTU exams. This Verilog code implements a 4 to 1 mux. A 4 to 1 multiplexer selects one input out of 4 inputs based on 2 select lines and sends that selected input to the output. Let's see line by line explanation. Consider the line 1. Here you can see module 4 underscore 2 underscore 1 underscore mux in bracket I0, I1, I2, I3, S1, S0 and Z. Right. So this is the first line of Verilog code. The keyword module is used to define a hardware block. Here 4 underscore 2 underscore 1 underscore mux is the name of the module. Inside the brackets we list all the ports of the module. Ports are inputs and output of the circuits. Here I0, I1, I2 and I3 are data inputs and S1 and S0 are select lines. Z is the output. This line tells Verilog what signal are connected to this multiplexer. Consider the line 2. The line 2 is input I0, I1, I2, I3, right? So this line declares the data inputs. The keyword input means that these signal enter the circuit. I0, I1, I2 and I3 are the 4 input lines of the multiplexer. Out of these 4 inputs, only one input will be selected at a time. See the line 3, that is input S1, S0, right? So this line declares the select lines. S1 and S0 are control signals. They do not carry data. They only decide which input should be selected. Because there are 4 inputs, we need 2 select lines. Consider the line 4. The line 4 is output Z. This line declares the output of the multiplexer. The keyword output means the signal goes out of the module. The output Z will carry the value of only one selected input. Consider the line 5. There you can see assign Z. This line uses the keyword assign. The assign statement is used in data flow modeling. It means the value of Z is continuously assigned. Whenever any input or select line changes, the output Z automatically updated. So let's take the conditions one by one and I will give you the explanation. Here the first condition is exclamation S1 ampersand exclamation S0 ampersand I0, right? So this condition is used to select input I0. Here exclamation S1 means S1 is 0. Exclamation S0 means S0 is 0. Here ampersand is the AND operator. So when S1 is equal to 0 and S0 is equal to 0, this condition becomes true. At that time I0 is passed to the output Z. Now second selection condition. The second selection condition is exclamation S1 ampersand S0 ampersand I1. So here this condition selects input I1. Here S1 is 0 and S0 is 1. When S1 is 0 and S0 is 1, I1 is connected to the output Z. Let's see third selection condition, that is S1 ampersand exclamation S0 ampersand I2. This condition selects input I2. Here S1 is 1, S0 is 0. When this happens, I2 appears at the output Z. Consider the fourth selection condition, that is S1 ampersand S0 ampersand I3. This condition selects input I3. S1 is 1, S0 is 1. So when both select lines are high, I3 is sent to the output Z. Here you can see a OR operator. All these conditions are connected using the OR operator. The OR operator combines all selection conditions. At any given time, only one condition will be true. So the output Z gets the value of only one selected input. See the last line, that is N module. This line marks the end of the module. Everything written between module and N module belongs to the multiplexer circuit. Thank you for watching this video.